Hello.
Hello.
Yeah. Uh, okay, have you guys tried the question? I had given,
Yes.
I think, two, three questions, right? Yeah.
Yeah.
S-
Hello?
Yeah. The first one is square root of ABCDEF is equal to DEF. And these are digits. You have to find the six-digit number.
Yeah.
Yeah.
Okay. So any progress here?
Well,
Um.
you can say DEF squared is equal to ABCDEF.
Mm-hmm.
And then if you write DEF as 100D plus 10E plus F, you get you can figure out like some digits. So
So
F,
basically, first of all, you should think of ABCDEF also in that pattern, right?
Yeah.
So if I write it like this, then we have 100D plus 10E plus F here, and we have something here. Should be equal to this square, correct?
yeah.
Yeah.
Okay. Um, so then have you guys tried something after this?
Well,
Um.
no, the square of F has to end in the digit F so that narrows possibilities to 1, 5, 6, and 0 for F.
Wait. Square of F will?
Because when you expand the square,
Hmm.
the only part that will have a
Okay, end
unit
in
sign,
F.
yeah,
So
will be F squared.
basically F square here, and every other term will be some. Okay, but you also have, okay, every other term will have 10 times something.
Yeah.
So it will not be in the units
Yeah.
place. So F and F have, this units place has to match with this units place.
Yes. And a similar thing is for the 100D and 10A squared, but that doesn't tell you as much.
Mhm.
So they're different digits. Um,
What can you say about the original two numbers, this number and this number? Like, think
Um.
of modulo something.
Maybe.
Both these numbers are uh, if you take modulo 1000,
oh, they're
what
both
will
DF.
it will be DEF here, right?
Yeah,
And this side will be what?
DF squared.
DEF square modulo 1000.
Yeah.
Yeah. So if they equal to each other, then DEF is
So
congruent
DEF
to
square
DEF.
is congruent to basically DEF mod 1000, right?
Mm,
Mm.
yeah,
Okay. So basically what we have is DEF square is congruent to DEF mod 1000. Correct?
Yes.
Yeah.
Okay, so that means DEF square minus DEF will be congruent to 0 mod 1000,
Oh,
right?
yes.
So we can take some stuff common here. DEF common, DEF minus 1 is congruent to 0 mod 1000.
Yeah.
Mm.
Okay. Let's see what we can figure out from here. We know that if there are two consecutive numbers, they are co-prime.
Yes.
Do you know that?
Yeah.
Yeah.
Yes.
So these two numbers are co-prime and it is basically divisible by 1000, right?
Yes.
So
Yeah.
1000 is 2 cube times 5 cube. So what can we say now? One of these numbers has to be odd and divisible by 5 cube, right? And the other must be odd and divisible by 2 cube. It cannot be a mixture of these two. 2 and 5 cannot come here and 2 and 5 cannot come
Oh,
here.
yeah. Yeah.
Why? Because if they are co-prime, you cannot have common factors.
Yes.
So one of the primes has to have all the 5s, one of the numbers has to have all the 2s,
Yes.
right?
Yes. Yeah.
So now we know that these two numbers, which are 3-digit numbers, these numbers have very limited possibilities now.
Yeah.
So basically, you should have uh,
You do not also consider if one of them is 0 mod 1000 and then the other is just any other number. Or
no,
just,
you cannot say 0 mod 1000 directly because how will you make 3-digit numbers which are 0 mod 1000?
oh, yeah.
You have to make the product 0 mod 1000.
Okay.
Uh,
That's what we are saying, no? That one of them has 2s and one of them has 5s.
Yeah. Yeah.
So let's think of the possibilities of DEF. DEF could be, for example, it could be 5 cube 125, right?
Yeah.
DEF could be 125. It could be, it cannot have 2, but it can be 3 times of 125, right?
Yeah.
See, this is not a prime factorization, so we can put extra prime numbers into it.
Oh,
We
yeah.
just know congruency. We don't know actual prime factorization.
Yeah.
yeah.
You understand what I'm saying right now?
Yes.
Like, I don't know what the powers of 3, 7, 11, and all are, right? In these
Yeah.
numbers. I know that finally when you multiply it, it is 0 mod 1000. And I know that these two numbers are co-prime.
Hmm.
So I can have 125. If I put DEF as 5 cube, I can have 125. I can also have 5 cube into 3. Correct?
Yeah. Yeah.
I
Yeah.
cannot have 5 cube into 2 here because I will put the 2's in the other number,
Yeah.
right?
Yes.
Yeah.
Yeah.
I can even have 5 cube into 5, 625 also. I can even have 5 cube into 7, 875 also.
Yeah.
But I will not do anything
Yes.
higher than that because this is a 3-digit number.
Okay.
Are you understanding what I'm saying?
Yes.
So
Yeah.
if DEF is taking these values, then the other number has to have powers of 3. DEF minus 1 has to be like 2 cube, which is 8, right?
Yeah.
Uh, or it could be 8 into, it can be 3, so 24. It can be 5. No, it cannot be 5. It can be 3, 8 into 7, 56 and all, right?
Couldn't it be?
It can be many numbers, but
Yeah.
these are the starting few, right?
Yeah.
Yes.
You cannot put 8 into 5, for example, right?
Yeah.
Because then if it has a 5, then they will not be co-prime.
Yeah.
Yeah.
So the first number here is 8. So we need to say DEF minus 1 should be divisible by 8, right?
Yes.
If you
Yeah.
take that first case, then DEF minus 1 should be divisible by 8, but DEF can take these 4 values. Which one minus 1 is divisible by 8? This one, right?
Yeah.
Yeah.
This is divisible by 8. It is 78 or something, right?
Yeah.
Yeah.
So then DEF is becoming 625 in that case, right?
Yeah.
Yeah.
Okay. So in that case, my number is coming what? DEF is 625 and DEF square should be ABCDEF, right?
Yeah.
Yeah.
So 625 square you will calculate. Uh, you'll get ABCDEF as check once 625 square. It is I think 390625. Which means it is fitting the conditions because DEF and at the end of that number is also a 625. If you get the value of DEF as 625, notice that the square is also ending with 625.
Yeah.
You have to use a calculator or calculate it and see.
Yeah.
Obviously, this was not the only possibility. We have not checked many other situations. Like, for example, we could have started with DEF minus 1 could be these, right?
Yeah.
Yeah.
And DEF had to be 8 and all, right?
Yeah.
So you should check those also. So if DEF minus 1 was 125, 375 and all, then DEF has to be divisible by 8. Then you can add 1 to each of the numbers, 125, 375, and see which one is divisible by 8, right?
Yeah.
And in that case, 376 is divisible by 8. Correct?
Yeah.
Yeah.
So in that case, you're getting DEF as 376, right?
Yeah.
So in that case, DEF square, 376 square, you should check and what it is coming. What is 376 square?
Uh,
14137.
So on the
yeah.
surface, it looks like it satisfies the condition again, right?
Yeah.
But the point that it is wrong is because there are repeated digits here.
Oh yeah.
Correct? It was no repeated digits here.
Yeah.
Yeah.
So we'll reject this answer
Yeah.
and we'll say our ABCDEF is 390625. So notice what we have done. The point is that since this is a 3-digit number, DEF mod 1000 is DEF only, right?
Yeah.
And
Yeah.
ABCDEF mod 1000 is also DEF. So we are saying that if you take mod 1000 on both sides, you are getting DEF squares is DEF mod 1000. And then we did this operation and we got to here. When we got to here, it's the product of two successive numbers
Yeah.
is congruent to 0 mod 1000, right? We are
Yeah.
basically trying to solve this congruence.
Yes.
This doesn't mean that we know prime factorization of the numbers. This means, however, that whatever is the product is divisible by 2 cube and 5 cube, right?
Yeah.
Which
Yeah.
means because they are co-prime, the 2's and the 5's should be separated, right?
Yes.
Like either this has all the 2's and this has all the 5's, right?
Yeah.
And we knew that these are
Yeah.
3-digit numbers also, so our choices are pretty limited. 125, 125 into 3, 125 into 5, 125 into 7, and so on.
Yeah.
And this starts with 8 and all, 24 and so on, right?
Yeah.
And then we are just checking. This is one way. Other way could have been this was 125, 375, and all, right?
Yeah.
And in those cases, we got two
Yes.
options for 3-digit numbers. One of them was not correct because it had repeated digits.
Yeah.
Yeah.
I hope you are understanding what is going on.
Yeah.
Yeah.
Okay. Question 2 was smallest natural number whose square ends in 2016. Okay.
Um.
So basically, since it's ending in 2016, the number is like it might have many other digits, but it ends in 2016, right?
Yeah.
So units,
Yeah.
tens, hundreds, thousand, this is 10,000's place, right?
Yeah.
So the final square should be some 10,000 into k plus 26.
Yeah.
So we have to find the smallest number n such that n square is equal to 10,000 k plus 2060.
Yes.
Okay. So now you can, once you have established this equation, only then you can begin trying to solve it. I hope everyone got to here.
Yeah.
Yes.
Then you can try to solve it and see what you can do.
Um.
If you haven't gotten the answer yet, try right now. You can try for 4-5
Mm.
minutes.
Yeah.
One hint is do this.
uh, uh,
Because this is easier to analyze. Now, this is much easier.
Yeah.
yeah,
You can take 2000 common also. You're getting 5k plus 1. And this is basically 2 power 4 into 5 power 3 into 5k plus 1.
Mhm.
Okay, so here there are two numbers. The product of these has to be something like this, right?
Yes.
Let's focus on 5 cube. The right hand side is divisible by 5 cube. Which of these will be divisible by 5? Can both of them be divisible by 5?
No,
Why not?
because they differ by 4. So if one is 0 mod, I mean, they differ by 8. So if one is 0 mod 5, the other
Hmm.
one will be like 3 mod 5.
Right. So we are sure that only one of them is divisible by 5, right?
Yeah.
Okay. So that comes from there. Now let's focus on 2 power 4. So is it possible? What are the possibilities? Both the numbers are divisible by 4. Both are divisible by 2 square, right? Or
Um,
is it possible that one of them is divisible by just 2 and the other one is
yes.
divisible by 8? Is it possible? Let's think about it. Let's say n minus 4 is equal to 2k,
No, it's not possible.
and n plus 4 is divisible is 8n. Is it possible? Why is it not possible?
Because um, they differ by 8. So if the one is 2 mod 8, then the other one will also be 2 mod 8.
Hmm. So basically, it is not possible that only one of them is 0 mod 8, right? If only one of them is divisible by 8 and the other one is divisible by 2, right?
Yeah.
It is also not possible that one of them is not divisible by 2 and another one is divisible by 16. You can check that also.
Oh, yeah.
Like if this one was 0 mod 16, then this is 12 mod 16. This is uh, minus 8, 8 mod 16, which is actually divisible by 2, right?
Yeah.
So we are eliminating all the other cases and we are getting that both of them are divisible by 2 square at least, right?
Yeah.
Okay. So now that we know this, so both are divisible by 4 and only one of them is divisible by 5, but the power of 5 is 5 cube, right?
Yeah.
So one of the numbers must be divisible by 4 into 5 cube, right?
Yeah.
Because the other number cannot have 5, right?
Yeah.
Do you understand?
Yeah.
Yeah,
So one of the numbers is divisible by 500 actually, correct?
Yeah.
correct. Yeah.
So we don't know which one. So we can say that the numbers are 500 into m plus minus 4, right?
Yeah.
If you multiply this and find n square now, our numbers are 500m into plus minus 4, either one of them, right? So if you find m square here, you will get, we need to say n square is equal to this, right? So we can say we'll get 250,000 m square plus 16 plus minus 4,000 n, right? Correct?
Yes.
Yeah.
And this has to somehow match with this 10,000k plus 2060, right?
Mm.
So now we can start from the smallest possible values of m because we want to get the smallest natural numbers, right?
Yeah.
We can start with m is
Yeah.
equal to 1, for example. If m is equal to 1, the numbers are 496 or 504, right? Correct?
Oh, yeah.
And if m is 1, our number here is becoming 250,000 plus minus 4,000 plus 16, right?
Yeah.
So notice that it will be 246,000 or 254,000 and 16, right?
Yeah.
Yes.
Or 254,016, but none of them ends in the 2016 that we want.
Hmm.
Yeah.
So this doesn't work, correct? So we'll try
Yeah.
m is equal to 2, and for m is equal to 2, you will get possible numbers are 996 or 1004, right? Correct?
Yeah.
And the
Yes.
square is becoming what? 250,000 into 4, so it becomes some 1 million or something. 4 into 250,000 plus
Yeah.
16 plus minus 16,000. No, plus minus 8,000, right?
Minus, like,
What are you saying?
wouldn't minus give you 2016?
When you do minus, right?
Yeah.
Yes.
You will get 992,000, right?
Hmm.
992,016.
Yeah.
When you do plus, it doesn't come, correct?
Yeah. Yeah.
So the minus one is giving us the right answer. That means 996 is our number, right?
Yeah.
Yeah.
You can check 996 square should be this.
Yeah.
I mean, obviously it will be because they have squared this only. And that will be the smallest number that satisfies the condition, because you can see 996 can be written as the product of uh, something n minus 4 into n plus 4, something like that, right? No, it is itself n minus 4 is 996,
Yeah.
correct?
Yeah.
So basically, the idea is come to here and then we think about the factors and then we look at the powers of 2 and powers of 5. And from there, we figured out that one of the numbers was divisible by 500.
Yeah.
And since we want the smallest natural number, if we write the numbers like this and check the squares, we can easily see which is the first time it becomes ending in 2016, right?
Yeah.
Yeah.
So that's how we figure this one out. Let's look at the next problem. This one was polynomial. Px was a polynomial with non-negative integer coefficients. Non-negative integer coefficients such that p of 1 was 4, p of 5 was 152, and we have to find out p of 11.
Yeah.
Okay, we can write any
Uh,
general polynomial as like this: an x bar n and so on till a1x plus a naught. This is my general polynomial. We know that the integer coefficients are there, so all the ai's are integers and they are positive integers or 0,
Yeah.
correct?
Yeah.
yeah.
Now you have to use the data to figure out things. So
As,
first equation comes something like this, right?
yeah.
And by the way, the condition that the integer coefficients are non-negative means each of the ai's is something like this.
Yeah.
Yes. Yeah.
Okay. Uh, right. And we also have P5 is 152.
Yeah.
Yes.
So now think about it. If you have tried it, tell me. Otherwise, think
Yeah,
about
I
what
think
it.
I
So
got it.
yeah.
How?
So if you check the case where, so firstly, they can't be like from a n minus 4 onwards. If the coefficient, oh no, from a4 onwards, uh, when you look at it, the case of P of 5, it will just be too big because x to the power of 4 would be like 625. So then
So you are saying that an 5 power n like this till a4 5 power 4 plus a3 5 power 3
yeah,
like this.
Yeah.
They should add
so
up to 152.
yeah,
So
so
obviously these should be 0.
yeah,
But you cannot have, okay, so then you need to know what is the n upper bound, right?
yes,
Basically,
the
n upper bound cannot be 4 because this cannot be 0.
Yeah.
yeah,
The first term of the polynomial cannot have degree 0 coefficient, right? Bec- If you talk about the polynomial as an nth degree polynomial, what it means is that n has to
oh
be
yeah,
3.
yeah,
Because if n was 4, it doesn't work by your logic only.
yes,
So we automatically know that n is 3, right?
yeah. And
Great.
then, so then what I did is I wrote it as a plus bx plus cx squared plus dx cubed. And
Mhm.
then, okay, for that, you can check pretty much a3 can either be 0 or 1. And for the case where a3 is equal to 1, you have that a0 plus a1 plus a2 is equal to 3.
Mhm.
And therefore,
Did you
and
get
then,
your polynomial px finally?
oh,
What
my
is your
final,
polynomial?
I got 2 plus x squared plus x cubed.
So that is the correct polynomial. Ultimately, it's now about solving equations and figuring out this, no?
Yeah,
Yeah.
It's not very difficult. You have conditions because the numbers are 0 or integers, either it will be 0 or 1 most likely. Right?
yeah,
You cannot have, it can be 1 here, you have to put 1 here. A3 is known as 1, right? Because that was the
yeah,
degree of our polynomial.
yeah,
And then
Yeah.
you are left with only 3 variables, A2, A1, A0, right?
yeah,
Then most likely you should put A2 as 1 so that you get to 150 and after that you can put 0 and 2 maybe, right?
yeah,
So it's not very difficult to solve and you can get P of 11 also, it will be 1454, right?
yeah,
But also one other way to think about it is look at this expression, right? This expression
Yeah.
that we have, P of 5, this looks like a number written in base 5.
oh,
Yeah.
Written in base 5. So if you had thought of that, then you can convert 152, which is in base 10, to whatever it is in base 5, right?
Oh yeah.
Like it
Okay.
is possible to convert the base, no, 152 to base 5 number.
yeah,
So like that process you need to know how to convert a number from one base to another, right?
Yeah.
Like the way to do it is divide 152 by 5, right?
yeah,
Correct, no?
yeah,
Yeah.
because the remainder, the quotients and all will start. Okay, I have forgotten the process, but what do we do? We keep track of the quotients, no, when you do binary.
Yeah.
Yeah.
Figure out how to convert 152 to base 5. If I divide by 5, what will happen? I will put I cannot divide the first one directly, so I'll have to divide the first two.
Yeah.
But this doesn't help us. Okay, I have forgotten, but you guys should find out.
Yeah.
Right now, the only thing I can think of is like 152 can be written as some same thing. We'll just figure out by calculation, right?
Yeah.
But there is a standard algorithm, by the way. Do you understand what I'm saying?
Yeah.
Yes, understand.
Taking any number, you should be able to find a way to get a number, the equivalent number in base B, right? There is a standard procedure for this, which I have forgotten, but you guys should figure out.
Okay.
The procedure is not what I would do right now is expand it and do the same thing that we did and solve for an minus 1 and all.
Yeah.
But that is not the
Yeah.
best way to do it.
Oh.
There is a better way to do it. And if you knew the better way, you would be able to say that this number is 1102 base 5.
Oh.
And if you knew this, then automatically, directly, you can read off the coefficients, right?
Yeah.
A3 is 1, A2 is 1, A1 is 0, A0 is 2. Correct?
Yeah.
Yes.
So what one of the things you need to go back to and figure out, if you search online, I'm pretty sure you'll get very good results which explain this process. Taking a number
Okay.
and converting it into any different base. There is an algorithm for it. You need to know it. I have forgotten.
Yeah.
Okay,
Okay.
because now notice that any integer polynomial, integer coefficients polynomial, right?
Yeah.
Any type of situation like this idea you should not forget, because if you know the value of, if you have suppose P7, right? P7 would be like a number written in base 7, right?
Yeah.
Yes.
Because this is like going to be base 7 representation, no?
Yeah.
And it will be like this. This is the number in base 7.
Mm-hmm.
Correct?
Yeah.
Yeah.
Correct.
So if the value of P7 was known to you, like 143, let's say, then all you have to do is convert it to base 7, right?
Yeah.
If you convert 143 in base 10 to something x in base 7, you have to just compare the numbers and you get all the coefficients.
Yeah.
Yeah.
So this is super powerful because all it requires is one conversion of base, right?
Yeah.
And you can read off so many coefficients.
Yeah.
I hope you're getting the sense of why it is useful.
Yes.
Yeah.
It will only work for integer polynomials, but we are doing number theory, number bases for that reason only. This is one
Oh.
of the applications.
Okay.
Okay. So
Yeah.
the homework
Yeah.
is taking a number 275, convert to base 8 to whatever base, right? Find
Yeah.
out the algorithm, how to convert. The conversion cannot be like by doing this. It cannot be, I will write it as 8 power n and an and find out these by solving. because
Oh,
that is the common sense thing, but that is too much effort. No, that is the same old thing that
Yeah.
we do all the time.
yeah.
There is a method to it. There is a division method which I have forgotten. So you have to find out.
Oh, okay.
So do that. I'll also give you a few problems to try. These should be interesting to attempt. So first one is this. Determine all positive integers n for which both the numbers 1, 7, 7, 7, there are n sevens, and 3, 7, 7, 7, there are n sevens, are prime. This question is Polish Junior Math Olympiad. Next one is let n is equal to d0, d1, d9. This is a number, and this is a 10-digit number with the property d of k plus 5 is equal to 9 minus d of k for k is equal to 0, 1, 2, 3, 4. You have to prove that n is divisible by 41.
Hmm. Okay.
Have you written down these two? Write down the questions.
Okay.
Yes.
Tell me when you've written both of them.
Yeah.
Okay, then the last question is this one. Let ABC be a prime number. Here ABC are digits. Prove that b square minus 4ac cannot be a perfect square. Okay. So these three numbers, these three problems you have to try and find the algorithm that I mentioned
Yeah.
Yeah.
for base conversion. After you have tried this, once you have attempted these three questions, we can do a class. Like it can be whichever day you are done with it, like Wednesday, Thursday, whenever.
Okay.
Just message me when both of you have tried these three.
All right.
Okay.
Then we'll have one more class most likely, which will be just more problems. And then the next topic in number theory that we have to do is factorials.
Yeah. All right.
So factorials is the next thing, but next class will still be the same chapter. So we'll continue.
Okay.
And yeah, message me when you guys are done and we can discuss the next thing.
Okay.
Okay.
Okay, that's all for now then.
Okay. Thank you.
Hmm.
See.
Bye.